Yes, welcome to our last video for week 3, and to perhaps the most important formula that we will learn this week, which you may not be familiar with yet. A bit complicated, but actually it just puts together what we have already learned so far. And at the end, they will also be able to calculate the task we computed at the very beginning, the corona example, together with us, and then they will be able to solve tasks of this type independently. The formula I mean is the formula of Bayes, and it exists in a more general form, which we see here. And then we will take a closer look at the special case for two events. It is quite similar to the formula for total probability. So we have our partition again, which in our corona example can be all the people who are positively and negatively infected. One could, so to speak, divide all people. That would be one possible variant. And then we have an event A again. And what we want to determine this time is, under the condition A, what is the probability of the event, EJ. Now let's take a quick look at this and think about it for a moment. In our corona example, we wanted to look at how likely it is that I am actually infected. So that would be, so to speak, one of those under the condition that I have a positive test. So you see, this is exactly what we want when we assume that the partition divides people into infected and non-infected. And what we have done here in the first formula is a very simple trick. And normally, what does it say here normally? Normally, it says PEJ cut A in the numerator. And what we have done is simply applied the multiplication rule. That's just simply the multiplication rule. And so we have written here in the numerator PJ times PIH. That means, and this is quite an exciting thing, we don't know this probability, but we know the reverse, which is the reverse question. How likely is it that if I am positive, my test will also be positive? And we know that this is a characteristic of the test, and that is good. However, we also have this PEJ included, and we know this because we know how many people are infected in total. That means we know that as well. And with that, it is already a very big help. And if you want to go even further now, you can also take a look at the denominator. And for the denominator, you can also use the formula for total probability. If one now wants to calculate P, so to speak, one could also do this through these categories and would then have the formula for total probability. This means that the formula you see here is ultimately a composition of using the formula for conditional probability, then for the numerator, the multiplication rule that you apply here, and for the denominator, the formula for total probability. This is a very complicated way. However, if we only have two events, namely E and not E, you can also, and then it will make the whole thing a bit easier. So here you see the formula. And this is exactly the formula we need for our corona example. And we will calculate that now. So here we have our situation. We will at least do A, and I would leave B to you. So we have the following situation again for everyone. We have a city with 1 million inhabitants. There are confirmed cases. We have these characteristics of the tests, and we want to know what the probability is that someone is actually infected with COVID-19 if their test result is positive. And now we first need to consider what our E is, so what our partition is. And we can basically divide all people into infected and non-infected, so E is infected. Then we have not E, so not infected, and our A is positive, tested. Okay. And what we want to know now is, what is the probability of being infected, given that the test is positive? So I will just write the formula down briefly for you once more again. It is exactly P of E times. We flip the whole thing around, divided by exactly. Now let's take a moment to consider the following details in the denominator section. So that is the probability of use and P of E times P of a given E plus P times P given E das, which is the probability of the event. Here is just the formula of Bayes that we have written down once again. And now we are interested in which of these 1,000 terms we know based on the text problem. Let's start with P. So, how high is the proportion of infected individuals? And we know this because it is the incidence of 1 million. That means approximately 10 to the power of 4, 10 to the power of 6, and that is 1/100th. Every 100th person, so 100 times, is 1 million. Thus every 100th is positive. At the same time, we know that the probability of not being positively infected, P, is 99 out of 100, which is the complement event. Together they are both okay. That's good. That means we know this. We know this. That. So, now we have the next term, which is oops. Now we have the next term. That is P of AE, which also appears here twice. Can we now consider whether we know that P of a given E, what is that? So E was infected, and A is positive. So the probability that the test is positive for an infected person is 95% or 0.95. So now we have one thing that we haven't used at all, namely the specificity. Yes, let's take another look at that. What is that again? The specificity means that the test will be negative for a not infected person. That is not E, which means not A. Okay, and that is 98%. What we want, however, is we want P of A under the condition E. But the fact is that both together add up to 100. Either it is A or A, they are the same conditions. This means we know that it is 1, 0.98, and thus 0.02. And with that, we are done. So now we have all the values we want, and we will write down the result. The result is we have P of E, which we have determined. So it is 0.01 times P of AE, which is 0.95, divided by P, which is again 0.01, again times 0.95 plus. What do we have here? P of E is 0.99 times P, which is 0.02. Yes, please calculate the result. I'm curious to see what you come up with, but this task is not that straightforward. Yes, so what did we do? We wrote down the formula. We defined all the events. Yes, we looked at what our E is, what our A is, and then we successively examined what can be extracted from this text, what information we have been given, and then we inserted it into the formula. Well, it's actually quite simple, just that, yes, there are different complexities involved. So we are done with week 3, and yes, with elementary probability theory. Next week, we will deal with an extension of the concept of probability and events, specifically with the concept of random variables. Until then, take care.